Have you ever wondered if we are really alone in the universe or if there's more to our existence than meets the eye? What if James Webb Telescope finally proves that we live inside a black hole? Join us as we find out more about this mind-bending, earth-shattering news that will leave you questioning everything you thought you knew about the universe. What are black holes to begin with? They're the stuff of nightmares. Sure, you may have seen them in sci-fi movies, but let us tell you, the reality is even more terrifying. According to some scientists, they're just pitch black holes in space, but the truth is a lot more complicated. Black holes are actually massive amounts of matter that are squeezed into an incredibly small area. Think of a star that's 10 times more massive than the Sun, all packed into a sphere the size of New York City. The gravitational pull is so strong that nothing can escape from it, not even light. Scientists have been geeking out about black holes for centuries, ever since they started thinking about objects in space that were so massive and dense that they could trap light. The most famous ideas about black holes were predicted by Einstein's theory of general relativity. Basically, when a massive star dies, it leaves behind a tiny, dense core. If the core's mass is more than 3 times the mass of the Sun, the force of gravity overwhelms everything else. It's a pretty cool and mysterious phenomenon, but also kind of creepy when you think about it. So how do scientists detect these black holes? These things don't emit any light, so you can't just point your telescope in their direction and snap a photo. In fact, detecting black holes is a real challenge. But scientists have found a way to improvise and infer their presence by observing their effect on other matter nearby. It's all about watching out for the signs. For instance, if a black hole passes through a cloud of interstellar matter, it'll pull that matter to it, a process known as accretion. But that's just the beginning. If a normal star strays too close to a black hole, it's game over. The black hole can tear that star apart as it pulls it toward itself. And as the attracted matter accelerates and heats up, it emits X-rays that radiate into space. That's how scientists are able to detect the presence of black holes indirectly. But the real kicker is this: black holes have a dramatic influence on the neighborhoods around them. They can consume nearby stars, emit powerful gamma-ray bursts, and even spur the growth of new stars in some areas or stall it in others. It's a mysterious and shocking phenomenon that's sure to give you the creeps. And where do they come from? Picture this: stars, once magnificent and blazing, meet their ultimate demise in a spectacular explosion called a supernova. From the remnants of these fallen giants, a mysterious entity emerges, the infamous black hole. Now, don't let their name fool you. These celestial enigmas aren't just any ordinary holes. They're like the vacuum cleaners of the universe, devouring everything that dares to come near. And you know what's truly eerie? Most black holes are born from massive stars, ones that have reached their celestial retirement party in a supernova blast. It's like the grand finale of their stellar existence, leaving behind a void of eternal darkness. Smaller stars, when they kick the bucket, transform into something called neutron stars. They're super dense, but not dense enough to trap light. However, if a star is a heavyweight champ, about 3 times the mass of our humble Sun, then a mind-boggling possibility arises. Theoretical gurus have proven that no force in the universe can prevent this star from collapsing under its own gravitational pull. Talk about a crushing destiny. As this mighty star crumbles, something strange starts happening. The surface of the star gets closer and closer to an invisible line called the event horizon. And here's where things get really trippy: time itself starts playing tricks. From the perspective of someone far away, time appears to slow down near the event horizon. It's like the star's own clock ticks at a different pace compared to ours. Until at that fateful moment when the surface touches the event horizon, time freezes, and the star can collapse no more. It's like a frozen implosion, frozen in time. Pretty spooky, right? But guess what? There's an even more haunting twist to this tale. Sometimes, when 2 smaller black holes meet in the cosmic mosh pit, they collide and combine, creating an even bigger and scarier black hole. And just when you thought things couldn't get any darker, imagine a black hole teaming up with a neutron star. Their deadly dance forms a colossal nightmare, a terrifying entity that defies all comprehension. Scientists have been struggling to wrap their heads around the scale of their sizes for years. It's like there's a sinister mystery surrounding them that we can't seem to unravel. The thing is, black holes come in two sizes, huge and small. But here's the catch: small is relative. Stellar mass black holes are remnants of massive stars and can be as large as 10 to 24 times the size of the Sun. And there could be as many as 10 million to a billion of them in the Milky Way alone. That's an astronomical number of black holes that could swallow anything in their path. But wait, there's more. Supermassive black holes are on the other end of the spectrum, and they're millions if not billions of times larger than the Sun. They exist at the center of large galaxies, including our very own Milky Way. It's like a gaping dark void that's pulling everything towards it. Stephen Hawking, a renowned physicist, talked about black holes in his lifetime. His lectures were always insightful, but some of his theories couldn't be confirmed due to a lack of necessary equipment. However, there's hope on the horizon. A single scientific instrument is changing everything, and we are not ready for it. It goes by the name of the James Webb Space Telescope, also known as JWST, and it's here to plunge into the depths of our universe. Let us tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to the potential of human ambition. Sure, we've launched other space telescopes before, and they've been doing their jobs just fine. But this bad boy is in a class of its own. The JWST makes the Hubble, which has dutifully served us for years, look like a mere speck in the cosmos. And the price tag of this astronomical wonder? A whopping $10 billion. Yes, you heard that right. That's enough zeros to make your head spin. And get this, it took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, not to mention the invaluable input from over 300 universities. But let's not forget the risks that come with such a grand undertaking. Oh no, this isn't a venture for the faint of heart. The JWST is venturing into uncharted territory, pushing the boundaries of what we know and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its minimum mission life expectancy of 10 years. Since its launch, the JWST has made many incredible achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside permanently. During its journey, the telescope successfully unfolded its massive 5-layer sun shield and giant main mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has fine-tuned and calibrated it, the telescope is almost ready to go into full operation. One of the most exciting things about the James Webb Space Telescope was when NASA announced that it had captured its first images of starlight. The first image taken by the telescope was of a star called HD 84406, and it resulted in a mosaic of 18 scattered bright dots from the star's light captured by the 18 mirror segments located on the primary mirror. NASA later released a new and improved image of HD 8446 in which 18 unfocused copies of the star were brought together in a deliberate hexagonal formation. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the image stacking process. This will bring 18 images on top of each other into one clear view. Thanks to its sophisticated technology, the JWST will help scientists investigate the early stages of the universe after the Big Bang. It will study what happened after the first stars formed, a period known as the epoch of reionization. This era refers to when neutral hydrogen was reionized, or made to have an electric charge again by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are very difficult to spot because of the way they interact with their host stars. Its powerful sensors will be able to observe these planets in more depth, including in some cases imaging their atmospheres. Understanding the atmospheres and formation conditions for planets could help scientists better predict if certain planets are habitable or not. Apart from studying the assembly of galaxies, scientists study galaxies to see how matter is organized on a gigantic scale. This, in turn, lets us see how the universe evolved. The spiral and elliptical galaxies we see today evolved from different shapes over millions of years. One of JWST's goals is to look back at the earliest galaxies to better understand that evolution. Scientists are also trying to figure out how we got the variety of galaxies that are visible today and the current ways the galaxies form and assemble. However, most importantly, the James Webb Space Telescope will help us answer the most profound questions of all: are we alone in the universe? And are we living inside a black hole? And JWST has already been on the hunt. And guess what it found? Compounds called polycyclic aromatic hydrocarbons, also called PAH, lurking around those gigantic supermassive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are like the goth kids of the universe. They're everywhere, from distant galaxies to comets in our solar system. Now, they're not just fascinating because they could be the building blocks of life, but also because they help astronomers track star formation. When ultraviolet radiation hits these PAH, they go all flashy and emit infrared light that can be detected by the JWST's mid-infrared instrument, aka MIRI. And that's usually a sign that there are some hot young stars hanging around. But wait for the plot twist. Our brave astrophysicist, Ismail Garcia Bernat from Oxford University, decided to take a peek at 3 active galaxies known as NGC 6552, NGC 7319, the spookily famous Stephan's Quintet, and NGC 7469. These galaxies are millions of light-years away in the depths of darkness. Now, what Garcia Bernat discovered will make your hair stand on end. In those central regions where the black holes reign supreme, MIRI found an abundance of pars. Sounds good, right? Well, here's where it gets chilling. The radiation near those supermassive black holes twisted the pars' very essence. It transformed them into larger, electrically neutral versions of themselves. The smaller, electrically charged pars vanished into oblivion. Imagine being devoured by the darkness itself. But wait, there's a glimmer of hope. The larger pars managed to survive because they found shelter within thin, dense, gas-filled clouds. It's like they found their own protective cloak against the horrors of the black hole's wrath. Now, you might wonder why this dark twist matters. Well, you see, it's a bit of a conundrum for astronomers who rely on PAH to track star formation. Star-forming regions tend to be all charged up with electrically charged pars. If those molecules are obliterated near the black hole cores, tracking where those stars are born becomes a real challenge. But fear not. Our fearless astronomers aren't backing down. Garcia Bernat and the gang are planning to dive even deeper into this dark cosmic abyss. They want to analyze more active galaxies, each with its own twist, to uncover the secrets of how these tough pars survive in such terrifying conditions. They're on a mission to unravel the specific properties of pars lurking in the black hole-infested cores of galaxies. And hey, that knowledge is the key to understanding star formation and how these eerie galaxies evolve over time. But there's another discovery made by the James Webb Space Telescope that takes the cake. Get ready for some spine-chilling news, because JWST has detected what could be the oldest black hole in the universe. This cosmic monster is a supermassive black hole weighing a whopping 10 million times more than the Sun. JWST was able to identify it by analyzing faint glimmers of light that date back to the very beginning of time itself. This dark, ominous discovery was found at the heart of a baby galaxy just 570 million years after the universe was formed. And get this, astronomers believe that there could be even earlier black holes lurking in the depths of space. It's fascinating yet terrifying to think about what other horrors could be hiding out there, waiting to be discovered. But one thing is for sure, the James Webb Space Telescope is giving us a glimpse into the darkest corners of the universe, and the things we're finding are nothing short of mind-bending. The discovery of the oldest black hole in the universe has sent shockwaves through the scientific community. This cosmic monster could just be one of many black holes that existed during the cosmic dawn, a period that started about 100 million years after the Big Bang, when the universe was just a billion years old. Astronomers are baffled by the sheer number of these black holes and how they grew to such colossal sizes. Although the researchers who discovered the latest black hole published their findings on the preprint server R14, the research has yet to be peer-reviewed. Lead study author Rebecca Ison, an astrophysicist at the University of Texas at Austin, believes that there could be many more black holes waiting to be found. She explained that the James Webb Space Telescope is allowing us to study cosmic history in a way that was previously impossible, and she's excited to see what else we'll discover. We've already discussed that black holes are born from the collapse of massive stars and grow by consuming everything in their path: gas, dust, stars, and even other black holes. But some black holes become so gluttonous that the material swirling around them heats up, causing them to emit light that telescopes can detect. These are known as active galactic nuclei, AGN, which we also call quasars. Supermassive black holes that are billions of times heavier than the sun emit blasts of light trillions of times more luminous than the brightest stars. To catch a glimpse of elusive black holes, these intrepid astronomers employed two remarkable infrared cameras, the mid-infrared instrument, MIRI, and the near-infrared camera. Armed with these powerful tools, they embarked on a cosmic hunt, scanning the sky in search of celestial enigmas. But it wasn't as simple as just snapping pictures. No, they needed to unravel the hidden mysteries concealed within the light. That's where the camera's built-in spectrographs came into play. Like expert detectives, they meticulously broke down the light into its individual frequencies, revealing a treasure trove of information. And there it was, amidst the faint glimmers from the universe's earliest epochs, an unexpected spike in the frequencies contained within the light. It was like a chilling sign, hinting at the presence of a black hole. It sent shivers down their spines as they realized that the intense heat surrounding the black hole was emitting faint traces of radiation spanning across the vast reaches of the cosmos. But the true enigma remained: how did these black holes form so abruptly in cosmic infancy? It was a question that haunted the dreams of these astronomers. They struggled to uncover even younger, hypothetical primordial black holes that may have come into existence just moments after, or perhaps even before, the colossal event known as the Big Bang. Yet, no matter how hard they searched, these primordial black holes remained maddeningly elusive. How did black holes come into existence and expand with such astonishing speed? Two prevailing theories emerged, each with its own flaws and mysteries. The first proposed that these black holes were remnants of colossal stars far more massive than any we see today. These ancient stellar giants would have formed at an astonishing pace, their birth and death a cosmic ballet beyond our comprehension. It was a tantalizing possibility, but time seemed to be the critical factor. The universe was young, and there simply hadn't been enough time for such a swift process to occur. The second theory, equally haunting, painted a different cosmic portrait. It suggested that dense clouds of gas, looming like sinister specters, suddenly collapsed upon themselves, giving birth to the insatiable singularities of space-time we call black holes. This direct collapse scenario was less likely but made sense for the rapid formation, requiring a significant amount of matter to plunge directly into the heart of darkness. Time, as always, was the constraint, time that seemed less in the early epochs of the universe. As the researchers delved deeper into the abyss of knowledge, another intriguing possibility emerged. It involved the elusive population 3 stars, a fabled class of celestial beings that were the pioneers of the cosmos. These stars, composed solely of hydrogen and helium, burst into existence in the universe's infancy. One such star, it was hypothesized, met a cataclysmic end, exploding in a brilliant display of cosmic fireworks. In its wake, it left behind a ravenous black hole, a cosmic devourer lurking in the shadows. But this black hole had a dark appetite. It dangerously consumed vast amounts of surrounding matter, growing at an unprecedented rate that defied stability, greedily swelling beyond what was expected. This strange behavior puzzled the researchers, raising new questions about the cosmic forces at play. Undeterred by the mysteries that surrounded them, the researchers joined forces with the creators of MIRI, forging a powerful alliance in the search for answers. Together, they embarked on a new mission, scanning the distant galaxies. Not content with just glimpses, but seeking a stronger signature of the elusive light within those emissions, they hoped to discover hidden secrets, a cryptic code that would unveil the enigma of the black hole nestled at the center of the ancient galaxy. We can only imagine what is waiting to be discovered in the vast expanse of the universe. But this isn't it for the adventures of our showstopper telescope, the James Webb Space Telescope. The ultimate cosmic detective has stumbled upon something truly jaw-dropping. Get this, it has detected not 1, not 2, but a whopping 6 colossal ancient galaxies that have earned the jaw-dropping nickname universe breakers. Why? Because they defy everything we thought we knew about the cosmos and could send current theories of cosmology into a tailspin. Picture this: these spectacular galaxies date back to a time when the universe was just a tiny infant, 3% of its current age. But here's the shocker: they are insanely massive. We're talking galaxies so ginormous that they make our very own Milky Way look like a mere speck of stardust. These universe breakers are strutting their stuff at a stage in the cosmic timeline when scientists were expecting to find nothing more than pint-sized baby galaxies. But oh no, these galaxies are mature, fully grown adults in a cosmic playground we thought was reserved for cosmic toddlers. So how did the James Webb Telescope stumble upon these cosmic giants? With its mind-blowing infrared sensing instruments, it sifted through the ancient light emitted by stars and galaxies, and guess what caught their attention? A series of fuzzy dots that were insanely bright and radiated a mind-bogglingly deep red glow. Now, in the wild world of astronomy, redness screams age. As light traverses the ever-expanding universe, it gets stretched out and turns redshifted. And you won't believe the age tag these galaxies had on them. They clocked in at a jaw-dropping 13.5 billion years old, sprouting up a mere 500 to 700 million years after the Big Bang. The previous oldest galaxies caught by the James Webb Telescope were already impressive at 350 million years old, but they were like little cosmic infants compared to these behemoths. The newfound universe breakers put them to shame with their mind-blowing mass. We're talking tens to hundreds of billions of sun-sized stars worth of mass packed into each of these mind-bending galaxies. They are like cosmic superstars, giving the Milky Way a serious run for its money. The existence of these cosmic monsters challenges everything we thought we knew about the birth of galaxies. It throws a massive cosmic spanner in the works of our current cosmological models. It forces us to question the very foundations of our understanding of how those first galaxies formed. Do we need to toss out the rulebook of cosmology or rewrite our ideas about how those baby galaxies were born from tiny clouds of stars and dust? Imagine trying to cram all those stars and cosmic material into such a tiny corner of the universe so early on. It's like trying to squeeze an elephant into a thimble. But these universe breakers did it, and they did it with style. They were like cosmic miracle workers, defying the laws of physics and dancing to the beat of their own drum. So what's next for these enigmatic universe breakers? Only time will tell, but you can bet your bottom dollar that the James Webb Space Telescope will be there, staring into the cosmic abyss and unraveling the mysteries of the universe one mind-blowing discovery at a time. And who knows what other cosmic wonders are lurking in the depths of space, waiting to be discovered? With the James Webb Space Telescope leading the charge, the future of astronomy has never looked brighter. So buckle up and get ready for the ride of a lifetime as we journey to the farthest reaches of the universe and unlock its deepest secrets. The cosmos awaits, and with the James Webb Space Telescope as our guide, the possibilities are truly endless. And there you have it, folks, the mind-blowing tale of the James Webb Space Telescope and its quest to uncover the darkest secrets of the universe. From ancient black holes to colossal cosmic giants, this intrepid telescope has shattered our understanding of the cosmos and opened our eyes to the wonders that lie beyond. So join us as we embark on this epic journey of discovery and prepare to witness the universe as you've never seen it before.